Hello everyone. In this video, let's discuss how to insert the element at a given position. Okay. First, we have to check the position. If the position is equal to 1, we have to write a separate logic. If it is other position, we have to write a separate logic. So first, I have to check a condition saying that if the position is equal to 1. If the position is equal to 1, I have to create a node first. After that, initialize the value. Done. After initializing the value, I have to take the value of head and that should be stored in new node's address part, because I might have so many elements in my linked list. Now the element which I'm going to insert is going to become my first node. So what I'm going to do is head is going to point to the first node. So that I'm going to take, I'll be storing in the new node's address part, because the new node becomes the first node and the already existing first node becomes the second node. So I'll be taking the value of head 2000 and that will be stored in the new node's address part. Afterwards, I have to take the new node address and that should be stored in head, so that the new node becomes the first node of the linked list. So this is the logic to insert the element at the position 1. Okay. If the position is not equal to 1, we have to go with other logic. Now let's discuss if the position is not equal to 1. So what should I do? I have to, let's take the position value equal to 3. Let's take the position is equal to 3. I want to insert the element at the position 3, that is after 20 I have to insert. So what I have to do? First I have to create a node. After creating a node, I have to initialize the value. Done. Now I have to start my traversal and I have to reach the second position. I'll repeat, I have to start my traversal and I have to reach the second position, because I have to insert the element at the third position. So I have to start my traversal and I have to reach my second position. So I'll be taking an object called temp. I'll initialize the value of head. So I'll give temp is equal to head. Head contains the address of the first node, that is 2000. Temp is also going to point to the memory location called 2000. Now with the help of temp, I'll be traversing the linked list and I'll reach the second position. Okay, for that I have to take a loop and I have to check the condition saying that for I equal to 1, I less than position minus 1 and then I plus plus. This is a condition I'm going to give. If the condition is true, I'll go to the next node, temp equal to temp dot next. So here I value equal to 1, position value was 3, 3 minus 1, that is 2. 1 less than 2, yes, condition is true. If the condition is true, what is the meaning? I have not reached the second position, so I'll go to the next node, temp equal to temp dot next. I'll go to the next node. Now I value will be incremented by 1, which becomes 2. 2 less than 2, condition becomes false, which means I have reached my second node. Which means I have reached my second node. Now what I have to do? I have to insert this newly created node between 20 and 30. So what I'm going to do is, I'll take temp dot next, the value of temp dot next, that I'll be storing in new node dot next. Okay. So in the new node's address part, okay, in the new node's address part, what I'll be storing? Temp dot next. Temp is pointing to the memory location called 3000. Temp is pointing to the memory location called 3000. Temp dot next is 4000. That I'll be taking, I'll be storing in the new node's address part. So that if I insert 25 between 20 and 30, after 25 I'll go to the node called 4000. Afterwards I have to change this node's address. So what I'll be doing? In temp dot next, I'll store the new node address. The new node address is 3500. That I'll store it in the temp dot next. Now I have inserted the value called 25 between 20 and 30. See, head contains the address of the first node 2000. I'll go to the data 10. The next node 3000, data 20. And the next node is 3500, which is nothing but the newly created node I have inserted between 20 and 30. That is at the position 3, 25. Then I'll go to next node 4000. Data is 30, null. That's all. We have inserted the element at the given position. This is how I have to insert the element at the given position. So if you are going to insert the element at a given position, you have to check two conditions. If the position is equal to 1, a separate logic. If that is not equal to 1, we have to traverse the linked list and we have to reach position -1. Then we can insert it very easily. Now let's go for the implementation of the program. I'll import the package. Import java.util.star. Okay. Class main. Okay. Public static void main string args. Okay. First, I'll define the node. Node consists of two parts, data part and the address part. Class node. Int data node next. Done. I'll create an object for the scanner class. Scanner s equal to new scanner system.in. Fine. I'll create head. Node head is equal to null. Fine. Now what I have to do, I have to get the size of the linked list. Int n equal to sc.next int. Let me insert the element in the linked list. So I'll start the traversal for I equal to 1, I less than or equal to n, I plus plus. Head is equal to insert end. I'll pass head, before which I have to get the value from the user. So int value equal to sc.next int. Head value. Fine. Now let's define the method. Public static node insert end head in value. Okay. So here first I'll create a node. New node equal to new node. I'll pass the value as the constructor. So let me define the constructor node into value. So data is equal to value and next is equal to null. Fine. Now what I have to do? I have to check a condition, that is if head is equal to null, I'll give the new node address to head and then I'll return head. Else I'll take temp, I'll initialize the value as head. So I'll be traversing till the end of the linked list. So while temp dot next not equal to null, if that is true, temp is equal to temp dot next. I'll be traversing. Once the condition becomes false, I have reached my last node. In the last node's address part, I'll be storing the new node address. Finally, I'll return head. So I have inserted the element at the linked list. Let me print that element. Print list head. So let me take a method called public static void print list not head. No temp is equal to head. While temp not equal to null, what should I do? I have to print the data. System dot out dot print temp dot data. So I'll give a space. Then I have to go to the next node. Temp equal to temp dot next. Okay. Let me check. So first I'll run the code. I'll give the size of the linked list as 4, 10, 20, 30, 40. See, I've got the elements. Now I'm going to get the position value from the user. Int position is equal to, first I'll insert at the first position. Okay. Then we'll insert at the some other position. Because we have two different logics, right? If the position is equal to 1, some logic. If the position is not equal to 1, some other logic. So if position is equal to 1. So let me get that also from the user. sc.next int. Okay. So insert at position. I'm going to call a method. called insert at position. So I'll be passing two arguments. What value I have to insert? That I have to get from the user, right? Int new value is equal to sc dot next int. So I'll be passing head and new value. Along with that, I'll pass the position also, because I should know which position I have to insert. Let me define the method. Public static, it has to return me the node's address. So I'll give head is equal to node insert at position. So here I'm passing three arguments: node, head, int new value, int position. Okay. So I'll be checking a condition. If position equal to 1. Here I have passed the value and if the position is equal to 1. If the position is equal to 1, first what I have to do? I have to create a node. So node, new node is equal to new node. New value, I'll pass it as a constructor. The value will be initialized. So after this, value will be initialized. Done. Now I have to insert this node. So what I have to do? The value of head will be taken. That will be stored in the new node's address part. So what should I give? New node dot next is equal to head. Done. Afterwards, the new node address should be taken. That should be stored in head. New node address is 3000. That should be taken. That should be stored in head. Head is equal to new node. That's all. This is we have to insert the element at the position 1. And then I'll give return head. That's all. This is the logic. So this I'll give it outside. Return head. Done. Okay. So I have given if position is equal to 1. What if position is not equal to 1? Let's write the logic for that as well. First I'll create a node. Node, new node is equal to new node value. As it is common for both, this I'll keep it as outside the condition. So this I'll take as creating a node and initializing the value is common. At whatever the position I'm going to insert, I have to create a node, I have to insert. So that I'll keep it as common. First I'll create a node, I'll initialize the value. Fine, I have created a node, I have initialized the value. Now I have to start the traversal and I have to reach the position -1 value. So if position is 3, I have to reach the second node. For that, I'm going to take an object called temp for the traversal. So here I have to start my traversal. So int I is equal to 1, I less than position -1, I plus plus. If I'm inserting on the position 3, I have to traverse, I have to reach the second position. So temp is equal to temp dot next. Here I'll be taking an object called temp. I'll initialize the value of head because I have to start my traverse from the first node onwards. So temp is pointing to the first node. Check I equal to 1. 1 less than 3 minus 1 is 2. 1 less than 2, yes, condition is true. If the condition is true, I have to go to the next node. So temp equal to temp dot next. I'll go to the next node. Now I value becomes 2. 2 less than 3 minus 1 is 2. 2 less than 2, condition becomes false. I'll come out of the for loop because I have reached the second position. After reaching the second position, what I have to do? In the new node's address part, I have to store temp dot next because this node should point to this node. This node's address is 4000. This is pointed by temp dot next. So what I'll give? Temp dot next is new node dot next is equal to, in new node's address part, new node dot next is equal to temp dot next. So this 4000 will be taken and stored. Now in temp dot next, I'll store the new node address. In temp dot next, I'll store the new node's address. In temp.next, I'll store the new node's address. That's all. The link will be created. So finally, I'll be returning the value of head from this particular method. I'll return the head for the traversal. That's all. Let me print the linked list once again. Print list. I'll give head. Let me save this code. Now let's run the code. So I'll give 4, 10, 20, 30, 40. So I've got the linked list. Now I want to insert the position called 1. The position 1 I'm going to insert the value called 50. Okay, there is an error here. We'll check what is the error. Okay, if this condition is true, I have to return. If I'm not returning, the below code also will get executed. So I'll give return head. If the position is equal to 1, after inserting, I have to return. This is a mistake we have made. Let's run the code once again. So 4, 10, 20, 30, 40. So I've got the linked list. Now I want to insert the position 1. The value is 50. See, 50, 10, 20, 30, 40. I have inserted the value called 50 at the position 1. So position I have given, which element I have given. Now let's run the code once again. Input value is 4, 10, 20, 30 and 40. I want to insert a value called 25 at the position 3. So position is 3 and the value is 25. See, 10, 20, 25, 30, 40. That's all. This is how I have to insert the element at the given position. That's all.